Hey guys, let's discuss about time domain analysis of RC circuit. Okay, so in previous class we discussed about RL circuit. Now let us discuss about RC circuit. Okay, so time domain analysis of RC series circuit it is. Okay, you please remember this is series circuit. So one this is a battery, one resistance and capacitor. So these two are connected in series. So we can call it as time domain analysis of the RC circuit. Okay, so this is a circuit diagram. Just observe this is a battery and this is a switch, so which is controlling the input voltage to the R and C. Okay, so again similarly as I explained in the RL circuit. So this is a VCT, so voltage across the capacitor and current across the capacitor. So these two responses we must calculate with respect to time. So we should, with respect to time, how it is changing, the response of the capacitor and of the voltage across the capacitor and the current across the capacitor. Okay, so now let us consider this a series circuit. Again we have to apply time intervals because is it the title itself is a time domain. So we should consider time at t is equal to 0, t is equal to 0 minus, t is equal to 0 plus, like that. So the initially switch is open, so no current will flow, and therefore this capacitor do not charge. It is under discharge, uncharged mode. So we don't apply any voltage. For example, this capacitor is in the condition of uncharged. So t is equal to 0. If you apply sudden, that will, what happens if t is equal to 0 plus and 0 minus. Okay, so t is equal to 0 minus nothing but before, just before closing the switch. We didn't close the switch, just before closing the switch. So this is also it is again uncharged, so the VC is equal to 0, and so we can say simply VC of t is equal to 0, capacitor is discharged initially because we are not applying any voltage. And then next condition is at t is equal to 0 plus, at t is equal to 0 plus, just to S is closed. Then the C definition, capacitor do not allow sudden change in voltages, sudden changes response. Okay, therefore again that's why at t is equal to just to switch is closed, then it act as a, the capacitor do not allow the sudden changes. So therefore VC of voltage across the capacitor again 0. So at t is equal to minus 0, at t is equal to plus 0, the capacitor response is, the voltage across the capacitor is 0, nothing but it's not charging, it is not charging. So therefore now we have to apply the time period t is equal to 0 plus continuously. So nothing but t is equal to infinity. So we have to close the switch for longer period time. So then see the how the capacitor is getting charged and till what time and what is the response, that we need to see. Okay, and so therefore when t is equal to infinity, so apply the KVL for RC circuit. So KVL nothing but the voltage across the resistor will become VR and voltage across the capacitor becomes VC. So when I apply the KVL, this input voltage is equal to sum of the voltage drops. Okay, so therefore, and so the VR, voltage of the resistor, and voltage of the capacitor is equal to V. So therefore VR you can write current into resistance, VC nothing but current into some reactance, XC, capacitive reactance, that is equal to V. So in both cases I is equal to IC equal to I, because current is constant because it's series circuit. So so if you write IC instead of I, the ICR is equal to VC plus V is equal to V. So that is the so equation, and for this we need to calculate the what is IC current. Capacitor current is equal to C dV by dt. This is a fundamental equation of the current across the capacitor. Okay, so now, so if so substitute this IC value in this equation, so you'll get, and RC dV by dt plus VC is equal to V. So dividing this equation both side by this RC, so they will get dvc by dt plus vc by rc is equal to v by r, v by rc. So let us say this is equation number 1. So this is called a first order differential equation of the RC circuit and of the RC circuit, and we have to compare with standard equation. What is standard equation? Di by dt plus pi is equal to q. This is a standard form. So when you compare the standard form, so you will get this equation. Okay, what is that? So this I of t, the I of t is equal to this complementary functions, and this forced response we can call it is. So this is v of vc of t, voltage of the capacitor, is equal to the combination of these two. This is known as the actually the cf, complementary function, natural response, is known as the natural response or source free response. Nothing but there is no source. It's also called as transient response. And this pi is called it as a forced response, that is q is equal to 0. So now we have to take this cf is equal to this natural response a into e power minus pt, and this response is pi, the forced response is equal to I of t, t is equal to infinity. So now this pi, so we got, now we have to substitute, and now we have to find total response by substituting these two, natural response and forced response. So this natural response vnt is equal to, and a into e power minus t. Okay, that q is equal to 0, v equal to 0, and when you compare it with standard equation, the p is equal to, you will get this is our equation. This is the first order differential equation of RC circuit. So if you compare the p, so and with standard equation, that p is equal to 1 by RC. So this p is equal to 1 by RC. So therefore, so here the p is equal to 1 by RC, then natural response of this one is equal to a into e power minus t by RC. So therefore v of t is equal to this one, and the vct at t is equal to infinity. So this is the actually we need to discuss here. So at t is equal to infinity, okay, if keep on increasing this, if keep on apply the voltage, so across the circuit, okay, so because we close the switch and immediately also there is no response, and after some time, if you keep on supplying the voltage at some interval of time at t is equal to infinity, so the capacitor gets charging continuously. At t is equal to 0, the voltage across the capacitor is equal to input voltage, that is vr, input voltage. So this vc is, it is equal to vr. So then there is no current flows in the circuit, because when current flows, nothing but there is a potential difference. So when this V input voltage is equal to Vc, there is no potential difference, the current will not flow. So till it gets fully charged, the current will flow. So at that time we have to finding here. So that is the time at t is equal to infinity. Okay, at some value, and you will get the capacitor voltage is equal to the input voltage. So that Vct of t is equal to V. So that is called actually that is a time period of the capacitor to get fully charged and equal to the input voltage. So now we see the total solution. The total solution is given by, so capacitor voltage of t at particular time period is equal to, this is the natural response, and this is the time t equal to infinity, the voltage is equal to input voltage. Okay, so for finding the value of a, we apply the initial conditions. So here t is there now, so this t value. So let us start starting condition. Now we got the final equation. In this equation, if we apply the t values, and we will get the total response. So vc of is equal to 0 is equal to a e power minus t equal to 0. Assume that at t is equal to 0, put t value here 0, and it becomes 0 and e power 0. So therefore a into e and plus v. So this is vc of c is equal to 0, and t is equal to 0. Therefore a is equal to minus v. This a value substitute in this equation. Therefore, VCT of t is equal to minus V AE e power minus t by RC plus V. So take both V here V is common. So V is equal to 1 minus e power minus t by RC. This is the actual final equation of the time response of the capacitor. So by using this equation, if you draw the graph about the capacitor, this will be the graph. Okay, at t is equal to 0 and VCT of is equal to 0 and t equal to RC and VCT of is equal to V into 1 minus e power minus 1. So what you get, how we get this one? T is equal to RC. So this is RC by RC will get cancelled is minus 1. So this is the final equation, and voltage across the capacitor at T is equal to RC, then that is equal to V 1 minus e power minus 1 value. This is the e power minus 1 value. Therefore 1 minus 0.367, that becomes 0.632 volts. So therefore, if you draw the graph, this is the time constant. Time is increasing. This voltage across the capacitor. So now we have to define the tau t is equal to RC. This is a time constant of RC. It is defined as time constant is the time in which the capacitor charges to 63% of its value. So the capacitor charges up to 63%. So this capacitor charges up to 63% at t is equal to RC. This is called time constant, because t is equal to RC means initial condition. We can apply t is equal to 2 RC, 2R by C, 3R by C, 4R by C, like that, so on so on, to get maximum value. Okay, so this is the capacitor charging, and after some time at t is equal to some period infinity, and your voltage remains constant as input voltage. So this is the graph of the time constant of the RC circuit. I hope you understand, and so if anybody has doubts, please mention in the comment section, so I'll get back to you. And in the exam derivation part, if you write till this point, this is more than enough, and it's very easy, and I hope everyone understand. Thank you so much.